UD3-71 ultrasonic portable flaw detector. Now you own the UD3-71 portable flaw detector. Instruments are delivered in a bag, where you will find the operating manual for UD3-71, installation CD for the Ultra UD7X software. Now let's closely see the flaw detector. Its completion set should obviously include the electronic unit of UD3-71 flaw detector delivered in a protective soft covering that protects the instrument from wet and dust while operating in field conditions. The serial number on the panel should coincide with the number in the registration certificate. Charger serves for connecting the flaw detector directly to the mains for charging the storage battery. Three cables, USB cable, mini USB, two similar cables with BNC LEMO. There should be two probes in a bag included to the basic delivery set: straight beam piezoelectric transducer, angle beam piezoelectric transducer. Protective hood that is attached to the flaw detector soft covering to ensure the good screen visibility in a daylight weather. Fastening belts that allow to have hands-free during the operation, that is most essential at heights and hard-to-reach areas. Let's see the electronic unit and its functionality. Connectors for piezoelectric transducers connection. Pulsar is marked in a green or black color, receiver in a red one. USB connector for connection the PC communication cable or synchronization cable. 3 mm calibration block, 40H 13 steel for sound velocity calibration that is specified on a calibration block. Charger connector, encoder connector, headphones connector. Battery compartment of a removable battery. Power button. Press this button to power on/off the flaw detector. Use mode key to select the rectification mode: radio signal, full wave, negative half wave, positive half wave. Use clear key to delete the memory element, also reset peaks in the peak hold mode. Use menu key to widen the signal zone of the flaw detector screen. Use steel frame key to fixate the image on the flaw detector screen. Use down arrow key to scroll down through the flaw detector menu. Use up arrow key to scroll up through the flaw detector menu. Electronic magnifying glass key is used for detailed examination of the signal shaped on the flaw detector screen. Use right arrow key to increase the value of a parameter chosen from the menu or for selecting the possible parameter values. Use left arrow key to decrease the value of a parameter chosen from the menu. Use step key to change the parameter step. Use this key to decrease the flaw detector receiving channel. Use this key to increase the flaw detector receiving channel. Use Enter key to confirm the data entering. Use Return key to return to the previous menu level. Let's perform the calibration of a straight beam piezoelectric probe. For this, connect the straight beam probe to the flaw detector connector using the cable. Power the flaw detector with power button. Then by pressing the Enter key, enter the pulsar menu and using Down key, set the auto synchronization. Then using up and right arrow keys, set the maximum amplitude of initial pulse. In PRF item, set the initial pulse frequency that equals 200 Hz. Then using Return key, return to the main mode of the flaw detector. Enter the receiver menu item. Here activate the filter and switch off the TCG, DUC and AGC function. Then return to the main menu of the flaw detector and move to Gate 1 item. In threshold item, set the measurement to be carried out by the signal peak. Return to the main menu of the flaw detector. Activate the probe menu item. In probe angle item, set the probe angle value that equals 0. In probe frequency item, set the value that equals the frequency of the connected probe. In probe type menu item, set the variant that corresponds to the probe that we have selected. Return to the main menu of the flaw detector. Move to the test piece menu and set the required value for sound velocity in the material. Return to the main menu of the flaw detector and again activate the probe menu item. Here activate the probe calibration submenu. Then move to straight beam probes menu. Then perform the following actions. Place the probe on the prepared surface of a block. By adjusting the gain, achieve the signal crossing the 50% of a vertical scale screen, that is alarm triggering. Adjust the scan in such a way that the screen shows the first and second back wall echoes. By adjusting parameters G1 start, G1 width and G2 start, G2 width, place the first gate on the first back wall echo and the second gate on the second back wall echo. In thickness H item, indicate the thickness of calibration block. Activate the AGC mode. Press Enter button in Measure item. As a result, the measurement of sound velocity is carried out in calibration block and delay in probe 0. Save the measured probe 0 value. Having set up the required gain value, move the gate to the first signal appeared on the flaw detector screen and compare the received value with the required one. Use electronic magnifying glass key for detailed examination of the signal shape on the flaw detector screen. Switch off the flaw detector. Calibration of angle beam piezoelectric probe. Firstly, connect the angle beam probe to the flaw detector connector using the cable. Use power button to switch on the flaw detector. Then by pressing the Enter key, enter the pulse menu. In PRF menu item, set the initial pulse repetition frequency that equals to 500 Hz. Then using the Return key, return to the main menu of the flaw detector. Activate the Probe menu item. Here, in Probe Angle item, set the required value for the probe angle. In Probe Frequency item, set the value that equals the frequency of a connected probe. In Probe Type item, set the variant that corresponds to the probe type that we have selected for testing. Activate the sub-menu Probe Calibration, then move to the menu Angle Beam Probes Calibration and select item using SO, it is calibration block, where we use the sub-menu Probe 0 using V2. Then you should do the following actions. Select the wave type that corresponds to the operating waves of a selected probe. Place the probe on the working surface of V2 block in such a way that the index point to be in front of the 0 mark of V2 scale. Switch on the AGC mode. Press Enter key in Measure menu item to activate the measurement of sound velocity and probe 0. Save the measured probe 0 value. Return to sub-menu using SO and activate item Probe Angle using V2. Place the probe at V2 block. Adjust the sweep in such a way to see the signal reflected from 5 mm diameter hole, then find this signal and achieve its maximum amplitude. By adjusting the G1 start and G1 width parameters, gauge the signal. Switch on the AGC mode. Press Enter key in Measure menu item to measure the probe angle. Save the measured probe angle value. Return to Probe menu. In X value submenu, set up the measured X value. Then you can return to the main menu of the flaw detector. Calibration of straight beam double crystal probe. Switch on the flaw detector. Connect the double crystal probe to the flaw detector. In Probe menu item, set up the operation frequency to 2.5 kHz. Enter the probe menu and set up the probe 0 value to 0 microsecond, the probe angle value to 0, the X value to 0 mm. Activate the straight beam double crystal item, switch on the beam of B correction. Set up the probe type double crystal. Exit the probe menu. Enter the Gate 1 menu. Set up the measurement mode to 0-1 and measurement threshold to front. Switch on the measurement marker in Pointer item. Exit the Gate 1 menu. In Test Piece menu item, set up the sound velocity value in built-in block. Enter the Probe menu and put the cursor in Probe 0 item. Place the probe at 3 mm in built-in block, previously creased with the coupling. If required, change the probe position on screen or the scan position and achieve the first backwall echo to be within the gate. When changing the gain, achieve the measurement to be carried out by the first negative half period of a signal. When changing the value in the probe 0 item, achieve the real block thickness to be indicated in the bottom information panel of the screen. The received value in the probe 0 is the true value of the delay in the probe which of a used probe. Exit the probe menu and enter the Gate 1 submenu. Enter the Display submenu and set up the parameter displayed on the screen, Y coordinate depth. When changing the signal rectification using the mode key, observe that the block thickness value is displayed correctly only when the measurement is performed by the first negative half period of the signal. Remove the probe from the built-in block. Check the accuracy of the depth gauge setup. Place the probe at 15 mm thickness block. When reducing the gain of a reception path, achieve the measurement to be carried out by the first negative half period. In the Test Piece menu, set up the required velocity in a block to 15 mm. Observe that the depth gauge is set up correctly. The result of thickness measurement is 15.02 mm. Calibration of Rayleigh wave probes. Connect the Rayleigh wave probe to the Flaw detector. Switch on the Flaw detector. Enter the probe menu. Set up the probe angle item to 90 degrees. In probe frequency item, set up the probe frequency to 2.5 MHz. Set up the probe type to SC, single crystal. Exit the probe menu. In Test Piece item, set the value of surface wave velocity in steel to 2900 meters per second. Enter the probe menu. Then enter the submenu Probe Calibration and then the submenu Rayleigh Wave Probe. After, enter the probe 0 using V1. Place the probe at the upper edge of V1 block so that the front probe edge coincides with 60 mark and the generating wave to be directed to the nearest butt end of V1 block. Adjust the scanned gate so that the signal from the upper end edge of V1 to be in the first gate and that from the lower edge of the same end in the second gate. Activate AGC mode. Press Enter key in the Measure item. As a result, the probe 0 and velocity of surface ultrasonic wave and V1 are measured. Save the value of probe 0 and, if required, the sound velocity. However, it should be kept in mind that the measured value corresponds to the velocity in V1. Return to the main menu of the Flaw detector. Enter the Gate 1 menu. Enter the Display submenu and set up the X coordinate displayed on the screen. Check the accuracy of the depth gauge setup. creating the DGS curves. Connect the straight beam single crystal probe to the Flaw detector. Switch on the Flaw detector. Enter the pulse menu, set up the PRF to 300 Hz and set up the amplitude to minimal as we will work at small thicknesses. Enter the main menu. Enter the probe menu. Set up the probe angle value to 0 and set the X value that equals 0. In probe frequency item, set up the probe operating frequency to 2.5 MHz. Set up the probe type item, single crystal. The DGS mode is available, in this case only. Return to the main mode. Enter the Gate 1 menu. In threshold item, set the measurement threshold peak. Enter the display submenu and set the displayed parameter DE, equivalent diameter. Return to the main menu. Enter the DGS menu and then enter the probe submenu, where set up the D crystal or S crystal of a used probe, the true value of a probe operating frequency, and if required, angle and probe 0. Exit the probe submenu. Activate measurement and curve items to ensure the calibration option. Enter the test P submenu, where set up the velocity, attenuation N and dB per millimeter or NP per millimeter. If required, enter coupling corrections or other corrections items. Exit the test P submenu. Enter the sensitivity calibration. In calibration effector item, select the type of calibration effector, FBH, flat bottom hole, and set the diameter of calibration reflector DCR, and do not set the depth of calibration effector. In VTP item, set the sound velocity in the calibration block. If required, set up the coefficient of acoustic attenuation in the block and in NTP item. Place the probe at calibration block surface and ensure the presence of acoustic coupling. By changing the menu items range and delay, ensure the signal to be seen within the screen frame. By changing the gain, ensure the signal from the calibration reflector to be within 40–70% of the screen vertical scale. In Gate 1 submenu, change the gate position in such a way that the signal from the calibration reflector to be within the gate and exceeded its surge level. Slightly change the probe position and change the probe pressure to the block to achieve the maximum value. When you achieve the maximum value, activate the Calibrate item by pressing the Enter key. The calibration is finished in case successful calibration following inscription is appeared. Exit the submenu Sensitivity calibration. In DE item, Acceptance equivalent diameter, or in SE, Acceptance equivalent area, set the acceptance level for DGS curve. After the calibration, the correct measurement of equivalent reflector, diameter 3.2 mm, is shown in the right up corner of the Flaw detector screen and does not depend on the DGS acceptance level and on the gain of the Flaw detector reception path. It is essential the signal to be within the gate and the screen height. Remove the probe from the block and exit to the main menu. In Sensitivity calibration submenu, select the type of calibration reflector, plain backwall echo. Place the probe at block surface and ensure the presence of acoustic coupling. When changing the gain, ensure the signal from the block to be within 40–70% of display vertical scale. In Gate 1 submenu, change the gate position in such a way that the signal from the calibration reflector to be within the gate and do not exceed its surge level. Slightly change the probe position and change the probe pressure to the block to achieve the maximum backwall echo. Having achieved the maximum value, activate the calibrate item by pressing the Enter key. The calibration is finished. In case successful calibration, the following inscription is appeared. By the echo signal from the 3.2 mm flat bottom hole, check the measurement accuracy of DE parameter after performing the calibration by backwall echo. Remove the probe from calibration block. In sensitivity calibration submenu, select the type of calibration reflector SDH side drilled hole. Place the probe at V2 block surface and ensure the presence of acoustic coupling. By changing the gain, ensure the signal from the calibration reflector to be within 40–70% of the screen vertical scale. Set up the depth to the side drilled hole center and its diameter. In Gate 1 submenu, change the gate position in such a way that the signal from the calibration reflector to be within the gate and exceeded its surge level. Slightly change the probe position and change the probe pressure to the block to achieve the maximum backwall echo. Having achieved the maximum value, activate the calibrate item by pressing the Enter key. The calibration is finished. In case successful calibration, the following inscription is appeared. Remove the probe from V2 block. Place the probe at block surface with diameter 3.2 mm flat bottom hole and find the signal from the side drilled hole. In Gate 1 submenu, change the gate position in such a way that the signal from the side drilled hole to be within the gate and exceeded its surge level. By the echo signal from the diameter 3.2 mm flat bottom hole, check the accuracy of DE parameter measurement after performing the calibration by the back wall echo. Remove the probe from calibration block. Connect the angle beam single crystal probe to the Flaw detector. Enter the pulsar menu and check the amplitude item to be set to maximum. Return to the main menu. Enter the probe menu. Check that all parameters correspond to the connected probe and exit to the main menu. In test piece item, set the transverse velocity in steel. Enter the DGS menu and then the probe submenu, where set the true value for the probe frequency and check the correspondence of other parameters. In VPR0 item, probe 0 velocity, enter the value of longitudinal velocity in the angle beam probe wedge. Exit the probe submenu. Activate the item's measurement and curve to ensure the possibility of calibration. Enter the submenu Sensitivity Calibration. In Calibration Reflector item, select the type of V2 D5 side drilled hole in V2 block at a depth of 20 mm. Place the probe at V2 block surface and ensure the presence of acoustic coupling. Slightly change the probe position and change the probe pressure to the block to achieve the maximum backwall echo. Having achieved the maximum value, activate the calibrate item by pressing the Enter key. The calibration is finished. In case of successful calibration, the following inscription is appeared. Creating the dark curve. Connect the straight beam single crystal probe to the Flaw detector. Switch on the Flaw detector. enter the receiver menu. Then enter the submenu TCG, that stands for Time Correcting Gain / Dark Distance Amplitude Correction, and in the mode item set up the dark. Play the prop at 50 mm thickness calibration block. Press Enter key on clear item to delete the current dark curve. In gate 1 item, achieve the signal to be within the gate by changing the position for gate 1. By changing the gain, ensure the signal of acceptance gate level to be crossed. Activate the Take a Point item to plot the first dark point. Place the prop at 40 mm thickness block. By changing the gain, achieve the signal to be within the screen vertical scale. In gate 1 item, achieve the signal to be within the gate by changing the gate 1 position. Activate the Take a Point item to plot the next dark curve point. Place the prop at 20 mm thickness block. By changing the gain, ensure the signal of acceptance gate level to be crossed. In gate 1 item, achieve the signal to be within the gate by changing the gate 1 position. Activate the Take a Point item to plot the next dark curve point. Place the prop at 15 mm thickness block. By changing the gain, ensure the signal of acceptance gate level to be crossed. In gate 1 item, achieve the signal to be within the gate by changing the gate 1 position. Activate the Take a Point item to plot the next dark curve point. Successively place the prop at all used blocks to check the dark curve to be plotted correctly. By changing the levels of 2 additional dark curves, it is possible to adjust up to 3 reference levels. In mode item, set up the TCG. By pressing Enter key on clear item, delete the current TCG curve. By activating the plot using dark item, plot TCG curve according to the taken dark curve by the level that was set up in the dark level item.